Greetings, this is Dr. Derek Ong with the next series of videos in terms of how to do statistical analysis using SPSS. In this video, I'm going to be looking at how we can do analysis on related samples, or sometimes it's also called paired samples, sometimes it's also called dependent samples. The first thing we need to know about when do we use paired sample t-test is to first understand the nature of our data. In the previous video, we demonstrated how we do independent sample t-tests on two independent populations. To understand the difference between independent and non-independent populations, we would need to then look at the nature of those populations. So for example, in the previous example, we had male and female, which were totally independent of each other in terms of their population. But for this example, we are using branch sales from 15 different branches. However, we are selecting their data twice. So for each branch, we are basically taking their sales before and their sales after. So it's kind of like having a time ordered data collection for each participant. If you see in terms of the difference for independent samples, we basically took the mean of the first population minus the mean of the second population, which was perfectly alright, and then we just wanted to see the difference. But in terms of related samples, we do not do this. What we do is we take individual differences. So for example, if we have 15 branches, we take the individual difference for branch 1, individual difference for branch 2, and then we sum all these individual differences and then we just want to check whether the mean of the individual differences is actually not equal to 0. So if the mean of the individual differences are significantly different from 0, then we can safely say that there is a significant difference in terms of the related samples. So first and foremost, you need to know what is the unit of analysis to be able to identify the whether we're using related samples or not. So for example, you may have a household and you wanted to check the difference between the husband and wife. So the paired sample would be the difference between husband and wife, because the unit of analysis here is the household. We might also want to look at effectiveness of a drug. So we can take the blood pressure of a patient. So we'll be looking at the difference between the patient's BP before the drug was administered and BP after the drug was administered. So we want to see whether or not the drug has been effective in reducing the blood pressure. So for our example here, we want to look at a rebranding exercise on a company, and we want to see whether that rebranding exercise has helped in significantly improving the sales for the branches. So this is a paired sample t-test, so we're going to go analyze, compare means, paired sample t-test. So what we're going to do here is I'm going to put the the sales after rebranding as the first uh, variable, and I'm going to put the before as the second variable. The reason that I want to do this is because I want to have my T, possibly because I'm postulating that the rebranding was successful and therefore the rebranding actually helped in increasing the sales. So I'm putting the rebranding as the second part. So I'm going to press OK, and we have the results. So if you can see here, it shows the mean, the paired sample correlations. I'll talk about correlation in a different video, but what we want here is the mean difference between after and before, the t-statistics, as well as the significance. So this is a significant results. So how we report this is, so the hypothesis here is there is a difference in sales before and after rebranding, and we would like to see if the rebranding actually increased the sales significantly. Note that this is only one population involved, so it is sampled twice before and after rebranding. And so this is how we report the results. The sales is significantly different before and after rebranding. T14 equals to 3.161. 14 is of course the degree of freedom here, and the P is less than 0.05, so therefore it is significantly different. So how do we know whether the significance? We usually checked at the 5% alpha level and the 1% alpha level to see where our T lies in terms of the rejection region here. Oh, I made a mistake. This should be it should be more, it should be less than, sorry, at two-tailed, T less than, and the T more than, yeah, sorry, same goes for this, and a T, sorry, T less than. So always check your T stats, make sure that they are less than negative 1.96 or more than 1.96 if you want to be at significant at 5%, and if you want to be at significant at 1%, make sure it's T less than negative 2.33 and T more than 2.33. So that's all about related sample t-test. If you have any questions, please send me an email. Thank you.